Hello friends, we'll solve a problem of a single unit load passing through the span AB of 15 meter and let C be the section of interest which is a distance of 5 meters from A. So influence, let us calculate reaction at A, reaction at B, shear force at C, bending moment at C by influence line diagram and check it by our conventional method. So when a unit load moves from A to B, influence line diagram for reaction at A will be this one. So this ordinate will be 1. Okay, when the unit load is here, reaction at A is equal to the unit load, that is 1, and as the load moves from A to B, reaction at A will be equal to 0 when the load is at B. Okay, then similarly when you draw the influence line diagram for reaction, when the load is at A, reaction at B is 0, that is this one. Then when the load moves towards B, the reaction goes on increasing, and here the reaction component will be equal to 1 for RB. Okay, so this is the reaction. So suppose when the load is at C, when the load is at C, so this is the ordinate. So this ordinate will be equal to, this ordinate will be equal to 1 by 15 is equal to 10 by 15. So this ordinate will be equal to 0.67. So if you calculate RA, so RA will be equal to 50 multiplied by 0.67 or 0.667. So this will be 33.33 kilonewton. Okay. Then similarly, if you calculate RB, when the load is at C, if you calculate RB, so here the ordinate will be equal to, this ordinate will be equal to 1 divided by 15 is equal to this ordinate divided by 5. So this ordinate will be 0.333 like that. So if you calculate RB, it will be 50 multiplied by 0.333, that is 16.67 kilonewton. So RA plus RB is equal to 50 kilonewton. So this is how we can calculate reactions at A and B by a particular position of the load. So it is a general method to calculate the reaction. Otherwise what you used to do is you should place the load 50 kilonewton, then by taking moment at A and B, we used to calculate reaction and A and B. Even if you calculate like that, you will get the same answer. You can check the answers by those methods. Okay, then let us calculate shear force. So when the load is in the portion AC, that is here, in that case the shear force at C will be equal to minus RB, that is here. So that is, so this ordinate will be 0.33. And when the load is in the portion CB, if you take the load here, in that case shear force at C will be equal to, that is RA. So RA will be equal to this one. So this distance will be equal to 0.67. So this is a maximum negative shear force and this is positive shear force. So this is a positive, this is negative. So maximum negative shear force will calculate first. Maximum negative shear force will be equal to this ordinate multiplied by the load, that is 0.33 multiplied by load is 50 kilonewton. So this will be around 16.5 kilonewton or 16.67 kilonewton. Then maximum positive shear force will be equal to ordinate multiplied by the load. Ordinate is 0.67 multiplied by load is 50 kilonewton. So this will be around 33.5 kilonewton. So otherwise if you calculate shear force also, it will be same. So at this position of the load, the reaction here will be 33.33. So if you consider left side, it will be 33.33. That is here calculated by influence line diagram. And if you calculate right side, then it will be 16.5. That is 16.67 kilonewton here. So you will get the same values. Then when a unit load moves from left to right here, then the bending moment at C will be equal to WAB by L or AB by L. So this is A into B by L. So if you calculate A is 5 meter, then B is 10 meter. So you will get AB by L will be equal to 3.33. This ordinate you will get 3.33. And if you calculate bending moment at C, it will be equal to ordinate multiplied by the load is 50. So that we will get it as 166.67 kilonewton meter. So this is how we can check it by putting the 50 kilonewton load at C and calculate reactions at A and B, calculate shear force at C, then calculate bending moment at C. So this is the influence line diagram for a unit load when it crosses the girder from A to B. So it will be WAB by L. W is equal to 1. So it will be AB by L. So we can use these influence lines for reaction at A, reaction at B, then shear force at particular section, bending moment at particular section generally. So now I have taken a load of 50 kilonewton. So you can take different loads and calculate these parameters, that is RA, RB, maximum negative shear force, maximum positive shear force, then bending moment at particular section with the help of the influence lines directly. So this is different from conventional method. So similarly, if the load is at some point D, then also you can calculate the reaction. So you can find this ordinate, then you can find here ordinate at D, then you can find the ordinate at D. So you can draw the influence line diagram at that point, and accordingly you can find the ordinates. Thank you.